Hello and welcome to our channel Practical Hope. This video is in continuation to our previous video, Introduction to SCILAB. So this is part 2. These are the topics that we are going to cover. User-defined functions, conditional branching statements and loops, introduction to plotting, 2D and 3D, and finally polynomial operations. Let's move towards the programming part. Now we will see how to define a function. Say we want to calculate the area of a circle for different radius, then we can define a function for the area of a circle, and then by giving different values of the radius we can calculate the area. So how to define a function? Function can be defined like this. First write function function space, so it will automatically write an end function. Function is to start and this end function is to end the function. First square brackets. Within these square brackets you need to write the output variables. So what is the output? You are getting the area. Say area we are defining by a. Then we have to give the name of the function. Say name of the function is circle. So whenever we are going to call this function, we'll call it by name circle. And what are the inputs? We need r, radius of the circle. Enter. Now I need to write the expression for the area. So area equal to pi r square. As we discussed earlier, we don't need to give the value of pi because pi is a internal constant in SCILAB. So we write percentage pi. It will automatically take the value of pi star r star r. So area is pi r square. Set the value of r, say 2, and how to call this function. Copy this and paste here. And now I can write DISA. We can display area. Now if I execute it, this is the area of the circle of radius 2. We can change the radius to say 3 and then again run. So you can see area has been calculated for radius 3. Now it's not necessary that in the function you have written here as a. You don't necessarily need to write here a also, right? You can here write say area on display area. Then also you should get the same result, because these variables that we are using, a in the function, r in the function, these are dummy variables. So when you are going to call this function, then the variables that you are going to give and the variables that you are going to get need not to be the same as you define in the function. You can also change this variable of r to say I and change here r to I. So it's actually this circle is the name of the function and it just need an input. It can be any variable. So just write I, and if I press execute, then you can see I'm getting the same result. Now a function can have many number of inputs and many number of outputs. Say we calculate the perimeter of a circle. So a comma p. Now we are going to get two outputs. Input is one only, that is radius of the circle, but you can have multiple inputs if you want to. If you want to add some more parameters. Let's write the formula for perimeter. P equals to 2 star pi star r. A area, p perimeter. So here also we need to change area comma perimeter. We need to change display also, and then again run. I'll get the area as well as perimeters. Actually it has become difficult to distinguish between the two, so what we can do, we can press enter. We can write in quotation marks area is, and we can write another display command perimeter is. So now if you execute the program, so now you can see area is 28.274334 and perimeter is 18.849556. So this is the function where we are getting two output parameters. You can get more than two outputs also. You can have more than one input also. Delete this. So next we are going to discuss two conditional branching statements. First is if else, and second is select case. Suppose I write variable a equals to -1, and suppose I want to check whether this number is greater than some other number, and then we can display our result whether the considered number is greater than this or less than this. So what we can do is we can check using if space. Automatically it will write then and end, because whenever there is an if, there should be an end. So if bracket a is greater than 5, say, then display a is greater, else we can display a is smaller. So now if you execute, you can see a is smaller. You can change inequality to say less than 5, and if you again run, then obviously a is greater. Or you can check if a equal to -1, then say we write numbers are same. If not, then we can write numbers are different. So you run, execute. So now you can see numbers are same. If you write say 5 and again run, then numbers are different obviously. So this is how you use if else statement. Next is the select case. Say we write b equals to 10 and say select b. We have selected b. Now we define our cases. There can be more than one cases. First case we define case say 5, then display 5. This is first case. You can also define second case, say case 8, then you can again display number is 8. So you execute. It's not showing anything because this number b is equals to 10 is neither 5 nor 8. That is case 10, then number is 10. Now if you execute it, so you can see number is 10 because this 10 has been compared with this b. Now suppose we do this 8 and we change this to 8 also, and we write say else display number is not 5 or 8. So we can execute now. Number is not 5 or 8. You can change the value to say 5 and then execute. So number is 5. If you press 8 and then execute, so number is 8. So we can either display, or we don't want to display, we want to do some arithmetic calculation, we want to do some logical operation, that also we can do. So these statements, executable statements of different cases can be set according to our need. Delete all these things and CLC, clear, clear. Okay. Next, how to do the looping. Here we are going to take two kinds of loops. First is the for loop and second is the while loop. For loop is pretty simple and straightforward. Suppose we want to do certain task for say n number of times, then we can use this for loop. For I is any dummy variable, equals to 1 to 10, right, and display I. So this value of I will be changed from 1 to 10 with the difference of 1. So I will take values 1 to 10 and it will display all the values. Then it will end. So execute it. You can see we are getting all the values starting from 1 to 10. Now this difference is by default 1. We can also change this difference. Say we want a difference of say 2. Write 1 colon 2 colon 10. So now it will change the values of I from 1 to 10 with difference of 2. Execute it. You can see 1, 3, 5, 7, 9. So this is a simple for loop. Instead of just display I, you can do other tasks also. You can also use if within the for loop. If I is greater than 5, then display. So that means if I is greater than 5, then only it will display, otherwise not. There should be another end. The second end is for and this first end is for if. Now if we execute, it will display only those values of I which are greater than 5. Let's execute. So you can see only 7 and 9. We can use multiple if statement also. We can use another for loop within a for loop also. So that is called nested looping. And finally, while loop. Say we define b equals to 5 and k equals to 1. Now how to define this while loop? Right, while space. So obviously while is also accompanied by a end statement. Here while loop will go on until the particular condition is met. Now we have to give the condition first. Say k is less than b. So whatever we are going to write here, this will be executed till k is less than b. Display k and k equals to k plus 1. So what it is going to do is b has been set to 5, k set to 1. Then first it will check whether k is less than b. Yes, 1 is less than 5. So it will display k and it will increase the value of k. So k is now 2. Then it will again execute. Now the value of k is 2. So k is less than b, 2 is less than 5. So it will again display and then again k will be incremented. In this way this loop will go on till k is less than b. The moment k becomes equal to or greater than b, then this loop will get terminated. Let's run this. We are getting those values of k which are less than b or 5. For loop is generally used where we already know how many times we have to do the iterations or the looping. But in while we set some conditions and the loop will go on till that particular condition is met. And if that particular condition is not met, then loop will get terminated. Next task is to do plotting. Let's write here CLF. CLF is to clear or reset the graphic window to default values. Suppose we want to plot two variables x and y. How to take the values of x and y? There can be many ways. Say we choose x is equals to line space 1, 10, 5. So it will basically generate equidistant numbers, equal spacing numbers between 1 and 10. And how many numbers it's going to generate? 5. Or we can also calculate it like this. Say x is equals to 0, 1, 360. So now x will vary between values 0 and 360 and the difference will be 1. So here also we are going to get equidistant points. We can change this 1 to 2, 3 as per the need. Now suppose I plot y equals to sin x and plotting can be done using plot x comma y. Now execute it. Okay, so we are getting this plot. Actually it's kind of sinusoidal, but the problem is it is taking these values of x in radians. If we want to plot in degrees, we need to write this sin d. So it will take values of x in degrees. So 0 degree and 360 degrees. So now let's plot. We can zoom it and this is the plot. Instead of the plot, you can also use scatter. So scatter means you are not going to get a continuous line, you will get discrete points. Let's execute. You can zoom it. This is the scatter plot. Actually, these are just points, not lines. So you can zoom it by scrolling your mouse. You can see these are only the discrete points. Unzoom and minimize this graphic window. Okay, so using scatter you can get the discrete points, or using plot you can get the continuous line. Now once I get this graph, I can give a title. Say I give it sine function. Let's give a label also. X label is, say, we define by capital X, and Y label we define by sin X. So we can get title, X label and Y label on the graphic window. Also we can write legend. Say we write sin X. Execute it. Let's zoom a little bit. So this is the title, this is the Y label sin X, then this X label X, and this is the legend. Instead of writing these X label, Y label and titles separately, we can write them as a single command. Close this graphic window. we write X title, and suppose we give all these three. Say we give the title first. So let's we put this title here, X title, and we don't need this title now. Then comma, we can write X label, delete this X label, we don't need this now. And finally this Y label, this also can be put here with the comma. So delete Y label, we don't need this also. Run it. Okay, so we have got the same title, x-axis, y-axis, and the legend. Now you can do various modifications to this graph. You can change the line width of this curve, change the color of this curve, change the font size of these labels, legends, and title. There can be two ways. One, by writing the commands on the sign notes window, but then it's difficult to memorize all these things. So the easy way is go to the graphic window and go to edit, axis properties. So this is the axis editor. First x-axis has been selected. You change the font size. This is the font size oblique color, it has been set to 2. Now we are increasing it to 3, 4, 5 and 6. So you can see the font size of X label has been changed. Similarly we can change for Y axis, so select Y. Now it has been set to 2, increase to 3, 4, 5, 6. So you can see. You can also change the color. Say we set to red. And next you can go to title. You can change the font size of the title also to 4, 5, 6. So you can see the font size of title has been increased. You can change the font style also. Instead of sans serif, let's say we select sans serif bold. So you can see font style of the title. Go to style and then you can change this thickness. You can see the thickness boundaries of the graph can be increased. Let's set it to say 5. Then line style also you can select. You can change these colors also, and you can change the font size also. Set it to say maximum. We choose font style to say sans serif bold. You can see they are bold now. Go to legends, select legend 1 and increase this font size to say 2, 3, 4, 5. This is the boundary, so we don't need any boundary for legend. Let's set it to white, so there's no boundary now. You can change the font style of the legend, say sans serif bold. Finally select this compound 1 and then this polyline 1. So this will give the property of the curve. So foreground color is blue, you can change it to say red, and then this is the line is solid line, and the thickness has been set to 1. We can change to say 5. You can see line width has been increased, or you can say increase to say 10. Right, instead of the solid you can get dash also, or you can get say dots also you can get. So different types of graphs you can plot. And say we change it to solid now. Now this X label is not visible, so go to edit and select axis properties. Close it, it will rescale accordingly. We are deleting this X title. Instead of one curve, we have plotted one curve only, we can plot two curves also. Say we take another variable z equal to cos d bracket x, and we want to plot both sine and cos simultaneously. So x comma y and comma x comma z. This is one way of doing it. Plot x comma y comma x comma z. So it will plot xy and xz. Now there will be two legends, sin x and cos x. Execute. So now you will get two curves. You can change the thickness of the curve. Say first curve, say you select 5, and then polynomial second you select 5, and you go to legend, increase the font size and make it bold. So you can see now we've got both sine and cos. This position of the legend sine x cos x can also be changed. This is the default position. Now we can change this position of a legend to say 1. So 1 is the default. So if you enter, then you can see the position of the legend is unchanged. Now if you write 2, then you can see it will change. Okay, so it has moved towards the left top corner. So this is the second position. Now here it will be the third, and if you write 4, then it will be the fourth. And if you write 5, then you can place it anywhere on the graphic window. Type 5, just cross this graphic window. Now execute. Now you can see it is moving along with your cursor. You can place it anywhere and just press mouse. You can place this legend anywhere on the graphic window. Instead of writing this x, y, x, z, you can simply do it in this way: x, comma, square bracket, y space z. In this way also any number of variables can be plotted against x. Now if you run it, so it is showing error, actually incompatible dimensions, because when you plot x with a different number of variables, then those variables should be column wise. Actually it plots them column wise. So we need to take the transpose of this, we need to take transpose of this, and we take the transpose of this. X, y, z transposed. So now if we execute, this is the graphic window. We can place this legend anywhere. Say now we place it here. So this is the graphic window. You can change thickness, color as we discussed earlier. So this is all about 2D plots. For 3D plots also we can use scatter, also we can use plot also. Now suppose we want scattered points, so we use scatter 3D. Delete this square bracket because now we'll plot x, y and z in 3D. Delete this legend now and run this program. So you can see this is a 3D plot. So you can rotate this plot in 3 dimension by right click of the mouse. You can see you are able to rotate it. It's a 3-dimensional scattered plot. Instead of scatter you can use plot 3D. Execute it. Actually there is some difficulty in displaying because y varies from 0 to 1 and z varies from -1 to 1, whereas x varies from 0 to 360 degrees. So this large difference is creating this problem. What we can do is we can press right click and rotate this graph little bit. So now you can see this is a 3D plot. Now instead of just getting one graph on the graphical window, we can divide this graphic window into a matrix, fixed number of rows, fixed number of columns, so that we can plot several graphs on the same graphical window. Suppose we plot both sine and cos. Delete this, plot 3D. So we first need to write subplot. We need to decide how many graphs we need to plot. Suppose we need to plot 2 only. So we just divide the graphic window to say 1 row and 2 columns, and there will be 2 plots. So the position of the first plot will be 1. Now we can write our plot function. First plot will be between x and y. Then again we'll have to write subplot. And now it will be 1, 2 because 1, 2 means 1 row and 2 columns. Now the position of the second curve will be 2. So again write plot x, z. And now if we execute, see now there are 2 different curves. Suppose we change this 1 row 2 columns to say 2 rows 1 column. Now again if we execute, then you can see now we have 2 rows and 1 column. We can divide the graphic window to any number of rows and columns, and you can then plot as many variables as you want. This is all about the plotting Let's delete this now. Delete this CLF also, because now we are not dealing with graphic part. So finally we need to know how to deal with the polynomials. So we define a polynomial P1 equals to Polynomials can be defined by the roots or by setting the coefficients of the polynomial. So if you want to define the roots, then we need to write this, say 3, 2. These are the two roots of the polynomial, 3 and 2. And what is the variable? Basically x. You can choose x, y, z, anything you want. Say we choose x, display p1. Now if you execute it, you can see polynomial whose roots are 3 and 2. By default these 3 and 2 are roots, but you can also specify, say r means roots. Whatever the inputs, whatever the values you are defining, these are the roots. So now if you again run, you can see, yes, so this is the same, because by default it will take 3 and 2 as roots, but you can specify them also. And suppose you change this r to say c means coefficients. So now this 3 and 2 will be the coefficients of the polynomial. So execute it. So now you can see 3 and 2 are the coefficients of the polynomial. So let's say we choose a third one, 3, 2, say -1. Again execute. So now you can see 3, 2, -1. So this is how you define polynomial. Suppose this is the polynomial. Now you can calculate the roots of the polynomial. Say ROTS, roots of the polynomial P1. So these are the roots of the polynomial, 3 and -1. So using this roots, you can calculate roots of any polynomial. You can also calculate the coefficients of a polynomial. Say this is polynomial P1 and you want to calculate the coefficients, COEFF bracket P1 and press enter. So these are the coefficients you can see. Now suppose we have this polynomial P1. You can also calculate the derivative of this polynomial P1. Write DERIVAT P1. Press enter. We are getting the derivative. We can assign this derivative to any variable, say ZZ. So now ZZ is 2 minus 2x. This is P1. And suppose we define another polynomial, say P2. P1, P2. So P2, it's P2, not P1. So execute. Now you can see we have two polynomials, P1 and P2. P1 is 3 plus 2x minus x square and P2 is 4 plus 2x minus x square. And suppose we want to add the two polynomials. Say we write P1 plus P2. You can see you can add two polynomials. You can subtract two polynomials. You can also multiply two polynomials. Then you can also solve first and second order differential equations. The link of this video has been given in the description box. Then there is another feature of SCILAB called XCOS. Basically you can simulate some electrical circuits, design some control systems. All these details about the XCOS we will discuss in our future videos. We have discussed many basic features of SCILAB. If you like this video, share it with your friends and don't forget to subscribe our channel if you haven't done it yet.